All right, let's look at the homework 14, problem number 3. All right, we're going to use the spherical coordinates to find the volume inside the cone, above the plane, and inside the sphere. All right, so let's draw a picture. All right, so it looks like a sphere has radius 6. So here's the sphere. Right, then we would have the x-axis coming out like that, and this is 6, and the y-axis coming out like that, so that's y-axis, and the z-axis coming out probably like that. Right, so that's 6 right there. Right, so that's z-axis. Alright, then we have a cone. Let's see if I can draw the cone. The cone is probably going to look like this. And look like that. Then you have that over there. And something like that. Right? And then it has to be above the plane, z equals 2. So it's cutting so you have a plane over here. Alright, so here this is z equals 2. And which will probably cut it around here. So that's 2 there. Alright. So we have, so it's above the plane and inside the cone and also the inside the sphere. So you can see that we're looking at this like a muffin here. So hopefully this looks right. So then something like that. Hopefully you can see this. So you have a muffin shape here, and we want to find the volume of this solid there. Right? So to set up the integral, I'm going to actually slice this muffin using xz plane. So it's going to look like this. So here I'm going to draw actually yz plane. I'm going to use yz. So here's y. And here is z. Alright, then if you cut it through a yz plane, the cone is going to look like this. So yz plane is x equals 0. So you have a 3z. So if you put the x equals 0, then you have a 3z squared is equal to y squared. Which can be rewritten as, let's see, z squared is equal to, by dividing by 3, y squared over 3. Then we can just take the square root. So z is equal to plus or minus 1 over square root of 3y. Right? So slope is 1 over square root of 3. So it's actually, my picture is kind of misleading. So this is the picture here. So this is z equals 1 over square root of 3 y. So this is a 1 in the square root of 3. So this is going to be 30 degrees or pi over 6. Maybe I should. This is a pi over 6 if we want to know. And then you have the negative 1. So going like that. Right, so this is z equals negative 1 over square root of 3 y. Alright, then you have the circle with radius 6, so it's gonna look kind of like this. Alright, so going through 6. Alright, then you have z equals 2, so z equals 2 is somewhere around here. Then cutting that off. Alright, so we're talking about this region right here. Alright, so that's the kind of cross section with the YZ plane. All right, so let's set it up. So a volume is equal to, all right, so it's gonna have, we're gonna have a triple integral here. All right, volume volume element for spherical coordinates would be r squared sine of theta dr d theta d phi. All right, so let's fix phi and theta. So for fixed theta, so I'm going to fix theta here. Theta there. All right. Then we have to figure out where it starts here and where it ends here. All right, where it ends is pretty easy because the radius is 6 on the sphere. So r equals 6 is the top end. And here we want to know what the r is. So let's make it larger. So if you look at the triangle here, right? So I'm looking at this triangle right here. Right? So this is theta, and this is 2. So if you want to find that, so if you have that, so what's that? We can find, let's see, cosine of theta is adjacent over hypotenuse, so it's a 2 over question mark. So which means that the question mark is going to be, take the reciprocal, 1 over cosine of theta. So which means that question mark is 2 over cosine theta. Alright, so it's r is going to start from 2 over cosine of theta. Alright, so that will take care of this segment here. Alright, so what we want to do is we want to start theta. Theta is going to start from 0, so this is going to be 0 there. Theta is going to be 0. Right? Then in order to swipe this half of this region, you can see that theta is going to be up to the edge of the cone. The angle here is, this is 30 degrees, so this is 60 degrees, so that's actually, theta is going to be pi over 3, because 60 degrees, because that's 30 degrees there. Alright, and once you've done that, so that will take care of this region here. Alright, and we can spin this around, spin this guy around 360 degrees to cover the entire muffin. Alright, so phi is going to start from 0, and then phi is going to end at 2 pi to cover the entire thing. So you can see that we take this region and swing it around 360 degrees. That would swipe the whole muffin there. Right? Then you can just evaluate this integral. Right? So I'll let you finish that. Alright, that's it. I hope that this was clear.